it's no different for you. I'll be posting it on this server, on this Discord server. So in this chat, maybe some mod can pin it after or something like that. And, yeah. So
I had a question.
yeah,
Are we gonna do it for like pi over 3? You know how we were doing it for 5 pi over 3? Did we already do it for pi over 3? Or
yeah, that was, I think that was the first one here. Yeah,
okay.
we did that. That was our first solution. Yeah. So we did pi over
Alright.
3, 2 pi, and then 5 pi over 3.
Okay.
So x, or so square root of x, is equal to 35 e to the I pi times the, 28, the cube root of 28, e to the I 5 pi over 3. Right? That's a 3. And so now we can just combine things that matter. So x squared equals 35 cube root of 28 e to the I, and so then this is 5, 3 pi over 3 plus 5 pi over 3, so 8 pi over 3. Right? Okay, now we need the square root of this, right? So, and plus 2 pi k, right? This thing right here. Okay, so now the square root of this, right, will be the square root of this thing, right? E to the I, and now this is going to be 4 pi over 3 plus pi k, right? Okay, and so now square root 2 solutions, it's going to be w naught is, k equals 0. So it's going to be the square root of 35 cube root 28 e to the I 4 pi over 3, because the k is 0. One solution. Our other solution, omega 1, is going to be 35 cube root 28 e to the I, so it's going to be 4 pi over 3 plus 3 pi over 3, so 7 pi over 3. There you go. And that's our other solution. And so there's our 6 answers from the text, at least for my question set here. Maybe if someone said they saw a teacher do this, were all the answers in a standard form or were they in polar form?
The question asks for standard form.
Let's
So
see.
like all of these are in polar.
Yeah, these are all in polar form. Let's see. Let me read the question here. Yes, express all your answers in standard form. Okay, so, well, I guess I'll do it. We'll see how many I do. So then to put these into, let's start over here, I guess. So the 2 green ones are these 2, of course. What am I looking at? So to put these back into standard form, there's not too much work. So if I just say, actually, I'll color code it like this. So w naught equals, so it's going to be the thing in the front, 35 cube root 28. And then remember, e to the I theta is just going to be cos theta plus sine theta I, right? And then, well, then you just figure out what that is, right? So, whoops. So square root of 35, cube root of 28. And then Noella, what's this now? So cos of 4 pi over 3. Yeah. Cos of 4 pi over 3 is negative a half. Plus the sine of that. Screwed up the calculator here. 4 pi over 3. And that's negative root 3 over 2. Over 2 I. And so now I would just, this is one step close to standard form, so since I have a bunch of questions to do, you just multiply it in, and there you go. That would be standard form. Right? Again, I don't know if the teacher would want you to simplify that. I would probably leave it as that. Right? And yeah, and so there you go. And so then I would do the same thing for all of them, right? So then that was for W naught. for W1, for specifically green W1 or omega 1, it's going to be just slightly different, right? In fact, I'm pretty sure I'm almost certain, and I'll just check now with this one, that it's just going to be the negative of this, right? So cos of 7 pi over 3 is, root 3 over 2. Oh, because I did sine. I didn't do cos. Cos of that is a half. Good. And then I saw this was root 3 over 2 I. So notice when you're taking the square root, right, it's just plus and minus, right? So this was the negative, positive. Right, it's multiplying. So really you can think of it as a negative in the front here. Gives you that one. Exactly. Okay, and so then for the rest of them, I'll do it over here. Well, this one's already in standard form. I could put a plus 0I, and now it's in standard form. And then for this one over here, we have the two solutions again. So then this is going to be, the recording will be posted. So this is going to be, let me see. Putting just into normal polar form. I don't know what I'm thinking. So the thing in the front, 35 cube root 28 times the polar form, so cos 2 pi over 3 plus sine 2 pi over 3 I, right? So root 35 cube root 28, so cos 2 pi over 3 pi over 3, so negative a half, and then sine of that angle. Sine of that angle. So root 3 over 2. Okay, and then I can right away tell you the other solution. So this was, oh, wait, green? Did I do the wrong color? Yeah, that's the wrong color, isn't it? That's the wrong, okay, whatever. The color coding broke now. So this is the blue section. I'll just do blue up here, I guess. So, well, no, you know what? I'll do it right. This will be orange. So omega 1, no, omega 0 will be that. Omega 1 will be that. That's the green. I'll erase this. Erase this. And look at this. Just select like that. And turn that blue. Oh, blue. That blue. Good. Okay. So then up here, this other one is going to be 35. Doesn't have to be purple, I mean orange. Cube root 28. And then this is going to be the negative of this. So 1/2 minus root 3 over 2 I. And there you go. There's your 6 solutions. Okay. So yeah, there's that question. Long question. You can see if I zoom out, you can see a better idea of how much writing it is. It's pretty much the whole thing. So then I'll move on to the next one, and then maybe after this one we'll go back to, we'll do some homework questions. So fine. So the question 2 is saying, unless anyone has any questions for this one that we just did, I'll move on to the next one. I think we're good. So question 2 from the midterm. So find all real numbers a and b such that the following system has no solutions, one solution, and infinitely many solutions. So the system is negative, for me at least, sorry, I guess I do realize it's different for different people, but for me it's negative 2x2 minus 6x3 minus 8x4 equals 4a minus 2b minus 3x1 minus 5x2 plus 9x3 plus 3x4 equals negative 3 minus 2a, and then 2x1 plus 4x2 plus a minus 2x3 minus x4 equals b plus 5. One more line, negative x1 minus 2x2 plus 2x3 equals negative 2. There you go. Okay, so that's our system. this one might be good actually if we, well, realizing now after I wrote all that it might be good if we do the homework that is relating to this first, but I'll give it a try. If it goes badly and I can't find an answer properly, then maybe we'll just skip it until I do the homework question for it, and then we'll come back to it after. So, well, look at this for a second. Yeah, the best way to go about this, find all numbers. Yeah, how I did it on the test, and I ended up with a weird answer, but I'm pretty sure this is the way to do it, is, well, first of all, turn this into a matrix, right? So the matrix would be 0, minus 2, minus 6, minus 8, and then 4a minus 2b. Next one would be minus 3, minus 5, plus 9, plus 3. So I'm going to have to write kind of, I don't know, somehow I have to organize this properly. 2, 4, a minus 2, negative 1. Oh, I didn't write the thing here. Negative 3 minus 2a, and b plus 5, yeah. And then this one is going to be negative 1 minus 2, 2, 0, minus 2. Okay. That's our matrix. So okay, so, well, I'm going to row reduce this now, right? I'm going to row reduce this to get it into a form where it's, I really just need that bottom row where it's the leading coefficient in this position, or the closest to that position as I can get, right? Which it'll be that position. And then from there I can decide how I can make this have one solution, two solutions, one solution, no solution, or infinitely many solutions. So, yeah, so I'll start row reducing. So this is going to be our, row 4 is going to be our top row, right? So I'm going to start by, I'll do maybe what will I do? Okay, I'll start by, first of all, adding row 1. So I'll write it over here. So row 2 plus 3, row 4. And row 3 minus 2, row 4. And then I know you're not really supposed to do it, but after all this, I'm going to do negative 1 times row 4. Right, so you technically shouldn't do that in the same step, but as long as I'm paying attention, just do that at the end, and it'll be okay. Okay, so the top row is staying the same. 0. So we're solving for, so the question is asking for solve for a, b, or just a and b. That's the only two variables, so that must be all it's asking for. Yeah, a and b, such that this linear system at the top here has a, one solution. Oh, sorry, a, no solutions. B, one solution. And C, infinitely many solutions. Infinite solutions. There. And that's and so that's what we're looking for. We're looking for A and B. So to do that, well, I got to put this into at least REF. I think just REF is fine. We don't have to do RREF. Yeah. So, okay, first row staying the same. 0, negative 2, negative 6, negative 8, 4a minus 2b. Yeah, you can just do REF. Minus 2b. Okay. Hopefully someone can also be paying attention to my math, because if I make a mistake, so my answer on this test, I'm certain I made a mistake, because at the end I ended up with this like insane expression for a and b, like it was some sort of literally wild, like crazy. Okay, here it was b plus 1 plus 4a squared minus ab minus 2b plus 5a minus 6 all over 6 equals 0. And that was one of my equations for a and b. And I had another one which I can't even see here somewhere. So I'm certain I made a mistake. You took a shortcut? We will see. So certain I made a mistake, because that doesn't seem like a good expression. So hopefully people can help me a little bit here with my math. So okay, so the first term is 0. That's the point. So row 2 plus 3, row 4. So negative 5 plus 3 times negative 2. So 3 times negative 2 is negative 6. Negative 5 plus negative 6 is negative 11. 9 plus 3 times 2, so that's 15. 3 plus 3 times 0, that's a 0, right? Yeah, is just 3. Good. And then this is where, we get a little tricky, right? So it's saying, well, no, this one's not that bad. So negative 3 minus 2a plus 3 times negative 2. So it's going to be negative 9 minus 2a. There you go. Okay, so the next one, just looking at 3 and 4. So row 2 minus 2 times row 4. So this one's going to be 0. It's plus... Oh, what did I do? Yes. Oh, yeah, that's right. Row 2. Why did I do the wrong one? Because I got confused because this is one of these is negative, so we want to subtract. Yeah, you're right. Okay, good. Someone caught me. Thank you for paying attention. That's wrong. So this is going to be a plus and minus switch there. Plus. So I should have checked that with the first one. So negative 3 plus 3 is 0. Thank you. Negative 5 plus 6 is 1. 9 minus 6 is 3. 3 minus 0 is 3. And then negative 3 minus 2a plus 6 is 3 minus 2a. Okay. Then 2 plus negative 2 is 0. Good. 4 plus negative 4 is 0. A minus 2 plus 2 is a plus 2. And then negative 1 plus 2 times 0 is negative 1. And then b plus 5 minus 4 is b plus 1. Okay. And then row 4 is I'm just multiplying row 4 by negative 1. So it's going to be 1, 2, minus 2, 0, 2. Okay, not bad. Right, so now I'm going to do... okay, I'll do row 1 now. So it's going to be row 1. Row 1 plus 2 row 3. Plus 2 row 2. Yeah. Okay, so the top row is going to become 0, 0, negative 2 plus 2. Good. Negative 6 plus 6, 0. Negative 8 plus 6, negative 2. So now, 4a minus 2b plus 6 minus 4a. So I'm just going to write that up. So, in fact, I'll do it on the side here. So 4a minus 2b plus 6 minus 4a. Yeah. And so then this will cancel, and it's just going to be 6 minus 2b. Good. Okay, and then the other rows stay the same. 1, 0, 3, 3, 3 minus 2a. 0, 0, a plus 2 minus 1, b plus 1. And then 1, 2, minus 2, 0, 2. Okay, we're not too... maybe we can already do something. Can we? Yeah, I think we can. Because remember, this is the augmented thing. Although this doesn't seem quite right. Did I make a mistake here? Yeah, what happened to the 4a? Oh yeah, that just turned into that. Okay, well, so what I can do now is I can say row 1 times, so row 1, I'll write it like that. No, that's a bad way to write it. So negative a half row 1. And so this is going to be 0, 0, 0, 1, negative 3 plus b, 0, 1, 3, 3, 3 minus 2a, 0, 0, a plus 2. Someone turn their mic on. I hear a nice...
There you go.
Okay, there we go. Hear a nice fan. Okay, and so now we have this, although I don't think I can actually do anything yet with this. This doesn't mean anything. Yeah, this doesn't mean anything yet. So I'm going to have to... Okay, first let me rearrange this. Maybe I'll get a better picture if I do that. So if I do that, it'll look like this. Move this one, so 0, 1, 3, 3, 3 minus 2a. And then I'll do 0, 0, a plus 2 minus 1, b plus 1, and then 0, 0, 0, 1 minus 3 plus b. Row 3 plus 1.
Can you go up a little bit, just a little bit?
Yeah, let me just put the matrix on this and then, yeah. Okay, here?
A little further up, please. Yes, thank you.
Question, or just you wanted to see what I wrote?
No, I just wanted to see that stuff.
Oh,
Because
okay,
I don't know for a second. Well, we're good.
Yeah, good. Okay, good. Okay, so yeah, someone said row 3 plus row 1. I assume you mean from this matrix. Yeah, row 3 plus row 4. Row 3 plus row 4. What will that do? I'm already in REF here. Yeah. I'm already in REF here. I can, although it doesn't do anything, yeah. Mm-hmm. Let's see what happens. Okay, so 1. So yeah, okay. Okay, sure. So row 3 plus row 4. But again, I don't see that. I see what that's going to do, but I don't see how that gets any closer to the answer. So 0, 1, 3, 3, 3 minus 2a, 0, 0. Okay, so still a plus 2, 0. And then it's going to be b plus 1 plus this, right? So it's going to be 2b minus 2, and then 0, 0, 0, 1, negative 3 plus b. But again, that's not, we're not any closer to the answer now than we were in the last step, as far as I can tell. So maybe if I'm wrong, then tell me. But so let's see my work here from before. Again,
I have another comment.
Yeah.
So I asked my teacher about this in the morning, and like same for the discussion, but pretty much for the REF that you made before.
This here?
Yeah, this one. If you want one solution, all it has to be is a cannot equal negative 2. Because if a doesn't equal negative 2, then there's all leading ones, so there'll be one solution. So that's for one solution. If you want no solution and infinite solutions, you have to first make a equal to negative 2. So that becomes 0. And then you can add row 3 onto row 4. And then you get the bottom row to be 0 equals negative 2 plus 2b. And then if you want no solution, then negative 2 plus 2b, negative 2 plus 2b equals 0. Negative 2 plus 2b equals 0 if you want infinite solutions, and if you want no solutions, negative 2 plus 2b does not equal 0. Yeah.
So, okay, so think about that for a second. Yeah, so if we have a... Yeah, okay, so right here, if we look at this term, if a is negative 2, then this will turn into 0, and we'll have a column without a 0. Well, we'll have a column without a leading coefficient, or a leading entry. And so then what that means is that that would be infinite solutions, wouldn't it? Because we'd have, this would be our parameter. X3 would be our...
So if it can kind of be like, you can think of it as like a branch or something. So if a doesn't equal -2, then it's one solution. But if A does equal -2, then it's either no solution or infinite solution. And then it depends on B to determine if it's no solution or infinite solution.
But why is it one solution? Why is there? Because if A's
Because apparently, if A doesn't equal 2, then it'll be a leading one. And if there's all four leading
yeah,
ones
I
there,
think I'm
then
just mixing up how you're saying how I'm thinking of it in your head. You're saying if A, so what I'm saying is that if A equals -2, then it's either infinite, or no solutions. Are we saying the same thing?
Yeah.
Okay, good. I was just confused how I was thinking about it in my head. Okay, yeah, because if right, what I'm saying is this would be 0. We have a parameter, so that means infinite, or it could possibly be no solutions. So that we have to decide first. But if we want one, so we already have A. So A is saying one solution if A does not equal if A is anything except -2. So there's one solution there. So now infinite solutions, okay, we know A is negative. Let's just assume A is -2, right? Yeah, so on the next, okay. Should I erase this? I think I might erase this one.
You can keep that. It's fine. Just
okay, well, I'll sub
A
in.
equals 2 to 0.
I'll sub in now A equals -2, because we know the only time that other stuff can happen is if A is -2. Okay, so 1, 2, -2, 0, 2, 0, 1, 3, 3, 3 -2, -2, which actually I'll just fully write this out. So 3 plus 4 is 7. 7, 0, 0, 0, 0, 2b minus 2, 0, 0, 0, 1, minus 3 plus b. Okay, we're in an interesting position here. So this looks like there's going to be infinitely many solutions, right? But only infinitely many if this is equal to 0, if 2b minus 2 equals 0, right? Because you can't, this doesn't make sense otherwise. You can't say 0 times x1 plus 0 times x2 plus 0 times x3 plus 0 times x4, 0 times all our variables. It can't be equal to anything except 0, which means 2b minus 2 has to be equal to 0. In other words, b has to be equal to 2 over 2, or b has to be equal to 1. So in that case, it would be infinite solutions. Any other number, you would have 0 times the first variable, 0 times the second variable, 0 times all your variables equaling some number. Well, that doesn't make sense. There's no way that can be solved, right? So then finally, our answers are going to be A. So for A, one solution, that means that A can anything except A equal to -2, right? B is, so B was one solution. So there's one solution if B equals 1 and also A equals -2, right? Oh, sorry, no. Wait, what? No. Sorry, A was no solutions. Let's let me rephrase that. I read the question wrong. So A, no solutions. When's there no solutions? When A equals -2 and B does not equal 1. There's no solutions. B, one solution, that's when A does not equal -2. And infinite solutions is when A equals -2 and B equals 1. And then there's infinite solutions. Okay, there's that answer for that one. Okay, any questions about this question? It was a tough one. So yeah, I had this crazy expression. Yeah, go for it.
I had a question about why does A equal -2? Is that okay? Could you repeat that? I was kind of confused.
So I got that from here. I got that from this step right here, where we ended up with that, right? So if you look at this, if I make A equal to -2, this will turn into this next matrix, right? It'll turn into this matrix over here, right? And so what you see. So I set that. What that gives us is a whole row of zeros. Notice a whole row of zeros, and so. Yeah. And also no leading coefficient there, right? So that means this is our parameter. This is our parameter t. Mm-hmm. So that means that there can either be infinite solutions or no solutions. That's the only time. you'll only have one solution when there's a leading coefficient in every term. And that will happen if A is any number except -2.
Okay, so like generally, like would the goal be to get at least like one row with all zeros?
And that'll help you, yeah. That'll help you get an idea of when you can get infinite solutions. Yeah, exactly. And so that's how you would do that.
Okay.
Okay, makes sense. And so then you got to kind of think about it like, okay, so if A is -2 and B isn't 1, then I'm going to have no solutions because it'll be a row of zeros, and then this will be some constant, which doesn't make sense. You can't have something equal to nothing. I mean, nothing equal to something. And then B is one solution. Well, that's anything except A equals -2. Doesn't matter what B is. And then infinite solutions if this is a whole row of zeros completely, including the constant, which is A equals -2, B equals 1. That's when you have an infinite solution, is when you have a whole row of zeros, including the constant. Okay. Oh, I didn't look at the thing. I'm looking at the chat. I'm reading the chat now. Yeah. Okay, so I was thinking maybe I'll do practice questions now from the text, or... Well, I don't know. We're kind of already in the middle of the test. Maybe let's just keep going on the test. I don't know. Maybe that's what I'll do now. I'll do question 3, unless people have something to say. So, question 3 is solve for all 2x2. Well, find A and B, which are both 2x2 matrices, such that the equations, it gives us 2 equations. 2 minus 1 minus 2, 3 times A plus 1, 5 minus 5, 1 B equals 1, 1, 0, 2 transposed. And, so it gives us a small system. So 2, 1, 2 minus 3 A plus O minus 4, 7, 3 B equals 1, 5, 1, 4 transpose. Okay, so solve for A and B. I did this like as if they were variables. I think that's the way to go. Again, I ended up with something wild. No, actually not that wild. I did end up with something that kind of made sense. It was just like, it had some fractions in my answer. Not even actually. B didn't even have any fractions. B was whole numbers. So maybe I got this question right. I just did it really fast. I was just like, I was big time rushing. It's terrible, sorry. But yeah, I was big time rushing. So, thank you. So, I would start by, first of all, doing the transpose on those two, right? So I will start with equation 1. Okay, equation 1 is where I'm starting. And I'll just rewrite it, but with the transpose. Okay. A plus 1, 5 minus 5, 1. B equals, so this is going to be 1, 0, 1, 2. Okay, and so let me rearrange for A, I guess. So rearranging for A, this will be 2 minus 1 minus 2, 3. A equals 1, 0, 1, 2 minus 1, 5 minus 5, 1. B, and I have to multiply both sides by the inverse. So we need the inverse of this now.
Can I suggest something?
Yes.
So if you just add the two equations together, the whole A matrix disappears. Because the A matrix is negative of the, like in equation 2, it's negative of the first equation. So if you just add them, like, you know, the elimination method, so if you just add them, the whole A matrix will like be gone. And all you have left is the B matrix equal to some other matrix.
That's a whole lot faster. A whole lot faster. Let's try that. Let's see where that takes us.
I figured that out like last minute of the test, and I didn't have time to finish it.
Would have saved me a lot.
Because I did what you did, and it took forever.
Yeah. Okay. In fact, so I'll just right off the bat transpose these from here, just so we don't have to worry about it, right? So it was, do I remember now? 1102. I'm pretty sure that's what the transpose was, and then this transposed is gonna be 1514. 1514. Okay. So yeah. Okay. So you can add the two lines together, right? So it's going to be this matrix plus this matrix is 0. So this is just going to cancel, and then it's just going to be, okay, it'll just be, I'll write it out fully. So 1, 5, minus 5, 1, b plus 0, minus 4, 7, 3, b equals 1, 1, 5, 4. Okay, and so now I can factor out to the right. I think I have to distinctly do it to the right. Right, and so then this will be plus 0, minus 4, 7, 3. All this times b to the right equals 1, 1, 5, 4. And now I just can add the term. So 1, 1, 1, negative 2, 4. Someone's on speakers.
Sorry. What happened to the in the first equation? It equal to another matrix. Did you add that as well?
No, I did not add that as well, and I should. Oh, I guess I didn't have to erase it. So I'm just adding this. So I'll actually just add it now. So 2, 1, 6, 6. 2, 1, 6, 6. Thank you for reminding me. And then this will be 2, 1, 6, 6. Yes, it should be positive 2. 2, 1, 6, 6. Good. And so now I'm going to do the inverse. I'm going to multiply both sides by the inverse of this matrix. So first of all, what's the inverse of that matrix? Well, boy, I have to remember now. So it's going to be 1 over 2 minus 4 times negative 1, 4, 2, 1. Is that right? Maybe someone who remembers how to do the inverse of 2 by 2, I forget now. Negative here. I might have messed that up, actually. That it might actually be fairly certain.
I think it's 1 over 4 minus 2.
1 over 4. Yeah. Let me just look it up. Inverse of 2 by 2 matrix. Google Images coming in helpful. Okay, yes. So it's going to be, so 1 over 4 minus 2 times 4, 1, minus 1, minus 2. I was completely wrong when I did this. Okay, let me just now. So this is going to be 1/2 4 minus 1 minus 2, 1, which is equal to, getting messy, I'll try to write it a little nicer. 2 minus 1/2 minus 1 1/2. Okay, so that's the inverse of that matrix. So I'm going to left multiply both of them by that. Okay, so then this is just going to be b equals, so 2 minus 1/2 minus 1 1/2, right, times 2, 1, 6, 6. Okay, so then my answer is going to have two columns. The first column is going to be 2 times the first column, so 4 minus 2, and our second column is going to be, oh, no, I did that wrong, plus 6 times the second no, hold on, trying to remember how to do this. Yes, plus 6 times this. So minus 6 over 2 plus 6 over 2. So that's our first column of the answer. U2 is going to be, what's it going to be? My phone. 1 times this column, so 2 minus 1, 6 times this column, so plus 12 plus 6 over 2. Okay, and so my answer for this multiplication, so b equals, so 4 minus 6 halves is 3, so 4 minus 3 is 1. Negative 2 plus 3 is 1. 2 plus 12. That's probably not right. Oh, yeah, no. What? Wow. 2 plus. What was that? 1 times 2. 1 times negative 1. 6 times negative half is negative 3. Where did I get plus 12 from? Minus 3. 6 times a half is 6 over 3. Okay. So then 2 minus 3 is negative 1. Negative 1 plus 3 is 2. Okay. There, that's B. Now to find A, we can just go back up to the top. Find either one. I will take, I guess I'll take the first one. So I'll actually just copy this. There. Oh, it didn't copy the, whatever. I'll draw it back after. Okay. And then we know B is that, so it's going to be 2 minus 1 minus 2, 3. A plus 1, 5 minus 5, 1. 1 minus 1, 1, 2 equals 1, 0, 1, 2. Okay, and we can just solve for A now. So 2 minus 1 minus 2, 3. A. Okay, so our answer is going to have 2 columns. I don't know if anyone else does multiplication like this, but I know my answer is going to have 2 columns, so I do column by column. So the first column is going to be 1 times this plus 1 times this. So 1 minus 5 plus 5 plus 1. And my second column is going to be negative 1 times this, so negative 1, 5 plus 2 times the second column. So plus 10 plus 2. 6 minus 4, 9, 7. Oh, maybe I shouldn't have done that here. Okay. 6 minus 4, 9, 7 equals 1, 0, 1, 2. I will just separate this a little bit. There you go. Okay. Move this over. 2 minus 1 minus 2, 3. A equals 1, 0, 1, 2 minus 6, 9 minus 4, 7. 2 minus 1 minus 2, 3. A equals, so 1 minus 6 is minus 5, 0 minus 9 is minus 9, 1 plus 4 is 5, 2 minus 7 is minus 5. And now, inverse again. So the inverse of that matrix is going to be 1 over 6 minus 2 times minus 5. Oh, no, looking at the wrong matrix. 3, 2, 1, 2. And so that's going to be 1/4, 3, 1, 2, 2. And I should actually multiply this. So 3 over 4, 1 over 4, a half, a half. Okay, that's the inverse. So left multiply both sides, going to be A equals 3 over 4, 1 over 4, 1 half, 1 half, times this matrix. Minus 5, minus 9, 5, minus 5. So A equals, okay, again, our, well, it'll be U1, no need for me to write it like that. I'll just do it like this. So the first column of our answer will be minus 5, yeah, minus 5 times this, so minus 5 times 3 over 4, and then minus 5 halves, plus 5 over 4, plus 5 over 2. That's our first column. Our second column will be minus 9 times 3/4 minus 9/2 minus 5/4 minus 5/2. Right there. There you go. And that's the two answers of our. So let's just punch that in. That's not 15. That's just a minus 5. So minus 5 times 3/4. Negative 15/4. Nope, plus 5/4. So negative 5/2. Negative 5/2 plus 5/2 is 0. And then negative 9 times 3/4. Oops, I can't type in my calculator for some reason. Times 3/4 minus 5/4. Negative 8. And negative 9/2 minus 5/2. And I didn't put the 5. 5/2 is negative 7. And there's our answer. There's A, and up there somewhere we found B. So, yeah, there we go. Okay. How does everybody feel about this question we just did?
Good question. I kind of forgot this. So why do we do inverse? Is it because like we can't divide matrices?
Exactly. Yeah, that's exactly right. Right. So if I have some matrix, say matrix A times some variable, right? Oh, maybe I shouldn't use A for both of them. Times X, right, is equal to some other matrix. Yeah, you can't just like divide both sides by A here because there's not really a way to divide. But what you can do is multiply both sides by A inverse, right, on the left side both. And what that turns into is the identity matrix times X, which is equal to A inverse B. And the identity matrix is like, it depends. So I guess in this case X is also a matrix. So identity matrix is just like in multiplication, 1 times X equals X. The identity matrix times some matrix of the same size is just equal to that matrix. Right, so one is the identity here. So it's, yeah. More specifically, the identity matrix is if it's like so I2 is 1, 1, 0, 0. Right, you can multiply any 2 by 2 matrix by this, and you'll just get the same 2 by 2 matrix out.
Yeah.
I3 would be the same thing, but bigger. Okay. So let me find the next question. So question 4. Question 4 was actually quick for me. It was only 1 page. Because I used to do this when I did this test, I was still using Photoshop instead of OneNote, so it was like 1 page of work. But it was, okay, so number 4 is solved by, determine A inverse using row reduction, no credit given if a different method is used. Use the result of part A to find the solution to that. Oh yeah, okay. I was gonna say, how do you find the inverse by row reducing? Why? And it's the way you find the inverse. I don't know. Something confused me there. So I'll say question 3. Hold on. Someone just texted me. 1 second, guys. Okay. So question 3 is we have this matrix A. A equals negative 1/5, negative 2/5, negative 4/5, 0, 1/6, 1/3, negative 1/4, 1/2, 1/4. Pretty complicated matrix. So find A inverse using row reduction. That's part A. And then we'll use this to solve a system of linear equations. Use the inverse, I mean. Okay, well, so to find the inverse using row reduction, what you do is you do this. You write out the matrix again. 1/6, 1/3, minus 1/4, 1/2, 1/4, and you augment it.
Adam, sorry to
Yes.
interrupt. Isn't this supposed to be called question number 4?
Yes, it is supposed to be called question number 4. Little things like that, I will never get right for some reason. I will make little mistakes like that. But I swear I can sometimes do the math. So thank you for that. So that's it. Wow. Bad bracket. Okay. Writing big matrices, my handwriting just goes terribly. So you put the identity matrix, you augment it with the identity matrix of the same size. And so then we are going to put this into RREF, not just REF. I think. Yes. We put it into RREF. So in other words, you're going to get you're going to put the identity matrix on the other side, right? Because RREF is just a diagonal of 1s and a bunch of 0s. And whatever's on the other side after all that, well, that is going to be your inverse. Okay. So, first things first, I'm going to multiply row 1 by 5 because it's all denominator of 5. Okay, and I guess I'll multiply row. I'll multiply row 2 by 6. So row 1. In fact, I'll do negative 5. So row 1 times negative 5, row 2 times 6, and row 3 times. I'll just do 4, not negative 4. Okay, so this is going to be I did negative 5 up there. Sorry. So this is going to be. So this is going to be 1, 2, 4, negative 5, 0, 0, 0, 1, 2, 0, 6, 0. This is going to be negative 1, 2, 1, 0, 0, 4. Okay, so we got rid of all the fractions. Still augmented in the middle there. Okay, so now I will do row 3 plus row 1. Yeah, I'll just do that. And I guess I'll do row. No, I can't do that. So I'll just do that next. So 1, 2, 4, minus 5, 0, 0, 0, 1, 2, 0, 6, 0. So 0, 4, 5, minus 5, 0, 4. Okay. Now I will do row 1 minus 2 row 3 and row minus 2 row 2. It's supposed to be a 2. Row 2. And then row 3 minus 4 row 2. So this is going to be 1, 0. So 4 minus 4 is 0. Negative 5 minus 0 is negative 5. 0 minus 6 is minus 6. 0 minus 0 is 0. 0, 1, 2, 0, 6, 0. And then now row 3 minus 4 times row 2. So 0, 0. Sorry, row 3 minus 4 times row 2. So 5 minus 4. Nope, 5 minus 8 is negative 3. Negative 5 minus 0 is negative 5. 0 minus 4 times 6. So minus 4 times 6 is minus 24. Yeah. And then row 3 minus 0 is just row 4 there. There you go. I'm going to, don't really have a choice. I have to start introducing fractions. So row 3, I'll do row 3 times negative a third. So 1, 0, 0, 0, 1, 2. Oh, I guess I should write everything. Minus 5, minus 6, 0, 0, 6, 0. So 0, 0, 1, 5 thirds, 24 thirds, 4, minus 4 thirds. Very close to being finished. One more step. So it's going to be row 2 minus 2 times row 3. So this side, notice, is going to be an identity matrix. Okay, so we're successful. So whatever is on the right side here is going to be our answer. So this stays the same, this stays the same, and now we just got to figure out that middle row. So 0 minus 10 thirds, so minus 10 thirds. 6 minus 48 thirds. Let's just do that here. 6 minus 48 thirds is negative 10. And then this is going to be 8 thirds. So 0 plus 8 thirds. So there you go. Okay, and so since we can do this, since we successfully got to RREF on the left side, right? Notice this is RREF, right? Well, that means that this thing right here is equal to A inverse. And so then we know A inverse equals minus 5, minus 6, 0, minus 10 thirds, minus 10, 8 thirds, 5 thirds, 24 thirds, minus 4 thirds. And so that's our inverse. We found the inverse. Is that what I found before too? Nope, that is not what I found before. Yeah. So either made a mistake then, probably made a mistake then, because I'm paying a little, like I'm going a little slower and paying closer attention now. Oh, maybe I didn't. 24 over 3 equals 8. Yep, probably. 24 over 3 is 8. Yes. Still need a calculator for some things. Good thing that wasn't, because I didn't have the chat open, so for a second I was like, oh my god, 24 over 3. Did I make a mistake early on calling 24 over 3 like some other number? No, yeah, you're right. That's just 8. So there you go. That's our inverse matrix. Okay. So now the next part of the question is to use this to solve this system. So the system is negative 1/5 x1 minus 2/5 x2 minus 4/5 x3 equals 2. 1/6 x2 plus 1/3 x3 equals 1, and negative 1/4 x1 plus 1/2 x2 plus 1/4 x3 equals 0. Okay. Well, one way to write this whole equation is to write it as a matrix of coefficients, A, times the vector of variables is equal to a vector of constants. So I could write that as 1/5 minus 2/5 minus 4/5, 1/6, 1/3, nope. 0, 1/6, 1/3, negative 1/4, 1/2, and then 1/4. So that's our A matrix times our vector of variables, right, is equal to a constants matrix 1, 2, 1, 0. A constants vector, right? Well, so now notice, okay, so sure, this is fine. But if we just go to our equation here, ax equals b, well, we can actually solve for our vector of variables here using A inverse, right? We do A inverse times both sides. Well, this just turns into x, the x vector, is equal to A inverse b. A inverse times b. We can do that. We have A inverse. So let's do that. So notice that this matrix A is equal to our original matrix A that we started with. It's the same matrix, right? So where are we? Here, right? And so what that means is that this is the inverse. So we can just do the x is equal to our inverse that we got. So negative 5, negative 6, 0. Negative 10 thirds, negative 10. I think it was 3. 8 thirds, not 3. 8 thirds. And then 5 thirds, 8. Negative 4 thirds. And we can multiply this by our constants vector, 2, 1, 0. Right? 2, 1, 0. Okay, well, this is something we can do, right? So the x vector is equal to 2 times, vector multiplication here. Well, vector times a matrix multiplication. So 2 times all these things. So negative 10, negative 20 thirds, 10 thirds. Yeah. Yeah, I can actually kind of write it like this. Plus negative 6, negative 10, 8. And that's it, because the last one's 0, so it's 0 times all these things. Okay, well then, so then our x vector is equal to negative 16, negative 20 over 3 minus 10, negative 50 over 3, and then 10 over 3 plus 8. 34. 34 over 3. And there's our solutions. So we solved the linear system, right? So remember, this is x vector is x1, x2, x3. That's what the x vector represents. So what that means is that x1 is negative 16, x2 is negative 50 over 3, and x3 is 34 over 3. And we solved the linear system. Right? So yeah. So any questions about this question? Have the chat open there. It was relatively straightforward. I mean, yeah, it was a pretty straightforward question. Doesn't mean it's easy, but there's one way to do it, pretty much. Okay. And then question 5, which I did not have time. I didn't even... I started a question, like I finished question 4, ready to do question 5. There were 4 minutes left on my timer when I was doing this, so didn't even start. So question 5 is saying, let M, AB, be a function that pretty much finds the determinant of this matrix, 1A, O, B, B1, O, A, 8, 7, 4, minus 5, A, B, O, 1, okay, where A and B are real numbers, so it's just a function, multivariable function, but still a function. Evaluate MAB in terms of A and B. Okay, so pretty much find the determinant of this, just leaving it as A and B's, and then use that result to find a specific value of the function, which is a lot easier. So yeah, so our first one, well, pretty clear what our first go should be. So right, we're finding the determinant of this. Well, we can choose any row or column to expand upon. I will choose this one because it's mostly zeros. So it's going to be 4. You know what? Maybe I'll do it in blue just to change it up. So 4 times, not 4 plus, but yeah, it is 4. 4 times the determinant of everything except that row or column, right? So 4 times the determinant of 1A, B, B1A, A, B1. Okay. So now 4 times, okay. Now the determinant of that. Well, we have to choose another row or column. So they're actually all identical, so it doesn't actually matter. So I don't know why I'm spending so much time choosing. I will choose, I guess I have to choose a different color. I'll choose I should choose that one. Okay, I'll choose that column. Right, so it's going to be 1 times the determinant of everything except that. So the determinant of 1A, B1. Okay. Then it's B, but it's negative B, right? So because we have to think about what position it's in. So remember this, it kind of goes like that. Right, and then it expands like that. So that's which ones are positive. So B, you see, is in a negative position. So it's going to be minus B times the determinant of everything except that. A, B, B1. And then plus A times the determinant of everything except that. A, B, 1A. Okay. So still 4 times, now the determinant of this is going to be 1 times 1 minus AB. So 1 minus AB. Right? And I will actually put this in brackets like that. Minus B times A minus B squared plus A times A squared minus B. So 4. And I'll move the 4 in. Actually, I'll just turn it into an expression. So it's 4, 1 minus AB minus 4B times A minus B squared plus plus 4a squared minus b. Okay, and so now it's going to be, I can stop, like I could stop at this line, pretty much. This is the determinant, but like if you want to be specific, I guess, simplify it more. So 4 minus 4ab minus 4ab plus 4b squared plus 4a cubed minus 4ab.
Isn't it plus 4b cubed?
Yes, it is 4b cubed. Thank you. 4b cubed. Yep, good. I was thinking, why is there an a cubed and not a b cubed? But yeah, there you go. Good. So well, just combine like terms. So it's going to be 4b. Well, I guess we start. These questions are the first midterm. They're the first. The first attempt at the midterm. Yeah. 4a cubed plus 4b cubed. Now just the ab's. Yeah. So minus 12ab plus 4, and that's equal to the function mab. Right, exactly. Okay, so then there we go. We solved it in terms of a and b. Now use the result to solve for m12. So it's just a function, right? So we just say 4 times 1 cubed plus 4 times 2 cubed minus 12 times 1 times 2 plus 4 equals that. So 4, 2 cubed is 8. So I'll just say 4 times 8. Minus 24 plus 4 equals m12. 4 times 8 is 32, so 4 plus 32 minus 20 equals m12. We post, yes, I will post this whole document after. Okay, and then now I have to do some addition. 34 to 16. Is m12 36, yeah. And there's our answer. And that's the whole test. We did the whole test. How long did that take? 2 hours? Yeah, an hour and a half. Took an hour and a half. And that's an hour and a half, like, well, I guess, how long did we have for the first attempt? Was it just an hour or was it 2 hours? I think it might have been 2 hours.
I believe we had 2 hours.
So this time I could do it faster. That's about
Good question. Why does A and B equal 1 and 2?
Oh, that's part B of the question. It gives us that. This is part B. It says solve M12.
Okay.
Right, that's what it gives, yeah. And so to find that, you just plug it into the formula we found in part A. Yeah, it is so much easier when there's no time stress, for sure. 100%. And it's also so much easier when I did this, since whoever told me that trick for this question, so I didn't have to, like, this took a while to do, like, to solve for A and B, the matrices like that. Yeah, that took a while. That took a big chunk of time. But actually, the biggest chunk of time was this question, because I had that crazy expression. Like, here we have a simple expression, 2b minus 2. But I had this crazy thing, first of all, with A's and B's, so I had to do solve the linear system of just that. And then also just took a long time. Yeah. It took us one hour. Yes. Yeah, for sure. But we can do it now, right? Number 3 from the linear algebra test, from the one we just did, and then I have the solution here. If anyone knows how to do, I mean, if that person's in the call. FKXP. Looks like FKXP might not be in the call, so they don't see. Yeah. So yeah, this will be posted. In fact, I'll just take this keep this as a separate document. Yeah, 5 we just did. 5 is this here. Pretty short question, actually. Yeah. So we're done. We're done the test. I'll keep going. I mean, we still have time. Let's still go for about an hour. We'll move on to some practice questions from the book. Let me just see this. I'll open a new one. So MTH 141. Yeah, I'll post it there. I'll do it right after because I can't actually export from OneNote in this version. I have to like open another version of OneNote, and that's where I can export it. But I don't like to draw in that other version, so I like to keep it. Anyways, more complicated than that. I'll do it right after. For which one? For 5? For which test? Oh, never mind. Sorry, you're talking to the other person, and I'm the one. Yeah. Okay, so let's do MTH 141 test 1 practice group, and then okay. So yeah, I selected those questions, which I don't have now. They're somewhere. Did someone pin it? No, no one pinned it. So let's see. I'll find it here. Linear algebra. Oh, it kind of goes back and forth, doesn't it? So I'll just start here. This one. And I'll just can I copy the whole thing? Okay. So these are the questions we're gonna do. In order, I guess. There's no reason not to really, unless someone has specific questions. But I looked through them, read them all. These were the questions I think are worth the time. Hopefully. So let's start with this. A23BD. So we're starting with chapter 6, back to our complex number stuff, right? So A23BD from Nicholson. Linear algebra with applications. So, no, sorry, wrong one. A23BD. Is that really the first one? A23BD? Oh, starting off with a kind of a hard one. Okay, well, not hard. More complicated one. I guess I did want this to be worth the time, so I did want to make some complicated questions. So, to put this on the side. At moments like these, I want 3 monitors, not just 2. Okay. So, A23. I'm gonna move this over. Move this to the side. Okay. A23B. So A23B says find all complex numbers Z such that Z to the power of 4 equals 2 root 3I minus 1. Okay. So, well, we're going to have to write this in polar form, right? So I will start by just rewriting this a little bit. So Z to the power of 4 equals, I think I'm going to multiply the 2 in, even though that probably is a waste of time. Probably don't need to. Yeah, I'm going to multiply the 2 in. So it's going to be negative 2 plus 2 root 3I. Yeah. Okay, and so now I'm going to start putting this into polar form, right? So, yeah, if everyone does agree, then we can do that. But sure. Or I can do less of them. I mean, I'll finish this question. But yeah, if people don't want me to do more, then I don't have to do more. So in polar form, I'm going to have to find the R value first, right? So R is equal to the negative 2 squared plus 2 root 3 squared. And so that is square root of 2 root 3 squared. So that's R equals 2 root 7. Okay. And then I will just, so I'm going to factor that out. So Z to the power of 4 equals 2 root 7 minus 2 over 2 root 7 plus 2 root 3 over 2 root 7. Yeah, okay. So then here, the 2's cancel. Oh, sorry, there's an I here still. I. Oh, changing colors all over the place. z to the power 4 equals 2 root 7 minus 1 over 7 minus 1 over root 7 plus root 3 over root 7 I. And I have a feeling I'm going to run into some trouble here because that doesn't look right. Yeah, whatever. Well, let's see if I can do this. So what's the... Does this even exist? Cos inverse of negative 1 over root 7. And, well, it does exist. It's just a long decimal. But that could be right. Wouldn't quite make sense. Did I make a mistake already? Is that how you're supposed to find the R value? I think.
I think R is 4.
Yeah. How? Yeah, it might be, but how? How did you get that?
2 squared and 3. Root 3 squared is 12, and 2 squared is 4. So it's root 16.
2, 3. Yes, it is 4. I don't know. I must have just punched into my calculator wrong before. Yeah. Somehow I got 2 root 7. Maybe I missed a square on the first time I did it. Yeah. Thank you. So this is just equal to 4. So I can factor out a 4 pretty easily. So 4. So factoring out a 4, it's a negative a half plus root 3 over 2I. Okay. Now I can write this in polar form, right? So this is going to, well, starting to write in polar form. So cos inverse of negative a half, well, so we know cos theta has to equal negative a half. We know sine theta has to equal root 3 over 2. Let's look at this. So cos inverse of negative a half, so that's 2. So this tells us theta is 2 pi over 3, and this will probably tell us a different story. Sine inverse of root 3 over, oh, I just did 3 over 2. Root 3 over 2 is pi over 3. So which one is it? This is pi over 3. Well, we're going to have to look at our CAST rule, right? So sine is positive, cos is negative, so we have to be in this quadrant, right? So that tells me that it should be 2 pi over 3, right? Let's check. Is sine of 2 pi over 3, sine of 2 pi over 3, is that equal to root 3 over 2? Yes, it is. So then our theta is just going to be 2 pi over 3. That's our theta. So you can write this as cos 2 pi over 3 plus sine 2 pi over 3i, right? And so then, well, now we're ready to put in polar form, right? So z to the power of 4 equals 4e to the I 2 pi over 3. And remember, we can add 2 pi k to that because it's cyclic. Okay. So now, where's that? Yeah, okay. So we're looking for fourth roots now. So to do that, we're going to do the fourth root of both sides, right? So it's going to be 4e to the I. Now this is going to be pi over 3. No, pi over 6. Pi over 6 plus, I wrote 2 plus signs for some reason, pi k over 2. Oh, and I didn't do the fourth root of this. So the fourth root of that. Okay. I kind of did a bunch of that stuff in my head, so if people are confused by that step, then I will expand it further. Right, but otherwise I'll just keep going. Okay. Don't worry if you're confused. I'll be happy to explain it. And this should not be to the power of 4 anymore. Okay, so well, now we can just find our 4 solutions, right? Because we're finding a fourth root. So our first solution, W omega 1, is going to be when k equals, sorry, omega 1 would be when k equals 1, but we're finding omega 0. So when k equals 0, So that's going to be the 4th root of 4 e to the I just pi over 6. Okay. Omega 1 when k equals 1 is going to be the 4th root of 4 e to the I and then pi over 6 plus pi over 2. In other words, 3 pi over 6 plus 3 pi over 6. So it's going to be 4 pi over 6. That's good. 4th root of 4. And then e to the I, and then that's going to be 2 pi over 3. Good, so that's our second solution. And then W2, k equals 2. 4th root of 4, e to the I. Okay, so then that's going to be just plus pi. So it's 7 pi over 6. There's our other solution. W3, k equals 3. Great. It's going to be the 4th root of 4, e to the I. So 3 pi over 2. I have to add 3 pi over 2, so that's going to be 9 pi over 6, so 10 pi over 6. 10 pi over 6. And there's our 4 solutions. And we can convert all these back to the standard form, but I think that's okay. I don't think I have to do that. Unless someone wants me to. In which case, just ask. But otherwise, I'm good. I have a cup of tea now in a nice math mug. I don't know if you can see. Here. Let me transfer to this. I have a math mug. It has a bunch of cool equations because I'm very cool.
I recognize Newton's second law, F equals ma.
Yeah. And it has other stuff we use too. I mean, it also has, can you see? I don't know if it says, well, you can't really see, but it also has like wicked equations, and it also just has 1 + 1 = 2 on it. So, pretty scientific.
Oh, wow.
Yeah. It has e to the I pi plus 1 = 0. That's pretty cool. That's what we're using. Has the zeta function. Has ideal gas law, chemistry, and other things.
Has a bit of everything. It's really cool.
Bit of everything, yeah, exactly. Okay, I'm gonna switch back to here. And I hope you guys like the transitions. I think they're pretty cool. And then next question. So yeah, should I do thank you. Should I do more chapter 6 questions? Or should I kind of, I don't know. Yeah, what do you guys think? Should I make another poll? I'll make another poll. Let's see. Straw. It'll take 2 seconds. Okay, poll. What to do? More chapter. All chapter 6. Some chapter 6. No more chapter 6. Okay. Great poll. There. Here, guys. I put a poll in the chat. Tell me what you think. And I will do that. Show results. Literary fish. How many people are in this call? Let's see. 28 people. So hopefully we'll get 28 votes. Give you all a second. Damn, I really be the only one voting for all chapter 6. Okay, I'll give it another second. So most people are voting for no more chapter 6. Some people are voting for some chapter 6. Oh, actually, maybe I shouldn't say the results until people vote. And I don't want to sway the people who are still voting and listening to me. So vote for whatever you want. Hey, someone else voted for all chapter 6. Thank you. I'll give it just one more second. Okay, so now it's 50-50 between some chapter 6 and no more chapter 6. So I think since it's 50-50, I'll do one more chapter 6 question, and that's it. Okay, so I'll do one more, and that's all I'll do. So, well, which chapter 6 question? Let's see. Let's see which one is the best to go for. So, I won't do D. It's okay. I'm just going to look at what's 6.3.5 in Kuttler. So 6.3.5 is kind of a tricky question. 6.3.8, just as tricky. A5BD. It's not very difficult. So actually probably not even worth it. 11, A11. Okay, so should I do, again, I keep getting, I'm not going to go poll for this one, but should I do either a question where it gives me an expression and I have to factor it into linear factors using this method, so finding the roots, right? Or should I do a quadratic formula question with complex numbers? Just whatever I see in the chat. Someone says quadratic, maybe upvote. Maybe someone liked that comment or like that message. If you agree, yes. Was that? Yes. There we go. Okay. So sounds like someone wants the quadratic one. So for the other ones, I think I will still have a session for them, but I'll just call it the chapter 6 review session, and then so you'll know. So we'll see. Maybe, I don't know about tomorrow. Maybe tomorrow. We'll see. Sometime I'll do just the chapter 6 questions separately, because I'm sure there's still some people who want to see chapter 6. I mean, there definitely are, because some people voted for some chapter 6, right? So, but I also do understand that I agree. We should move on. So let's do the quadratic question. The quadratic question is asking... Here, I said B. So let's just do maybe B. And I remember having trouble with these questions. I think I could do D. Let's try D, because I think I could do it. So let's not do one that I can't do. So A11, D, is saying, so x squared minus 3, 1 minus I, x minus 5I equals 0. Solve for x. Okay, so A equals 1, B equals negative 3, 1 minus I, C equals negative 5I. So we just stick this into the quadratic formula. X is equal to 3, 1 minus I, plus or minus the square root of minus 3, 1 minus I squared, minus 4, minus 5I, all over 2. Okay, just like that into quadratic formula. Let's work with this. Oops, not 3. X is equal to 3 minus 3I plus or minus, so it's going to be 9, 1 minus I squared plus 20I. And I think I remember being stuck here for some reason. Not at this step, but 3 minus 3I plus or minus, oh no, never mind. Actually, never mind till the never mind. Okay. So 1 minus 2I minus 1 plus 20I. Oh, this is supposed to be a square root. Yeah, I'm going to be stuck with some... Yeah, this is the one where I'm stuck with root I, and then root I is something fancy. Okay, hold on. Maybe let's do a different question. Unless people want to see me deal with root I. We will not have to deal with... I mean, actually, I shouldn't say it so confidently. We might have root I questions, but I doubt they're going to give us something like that. Because they didn't actually teach root I. So, because I'll at least get to the end of until I can do. Yeah, there is a formula for root I, for sure. So, 1 minus 1 is 0. So it's going to be negative 18I plus 20I in a square root, all over 2. So x equals 3 minus 3I plus minus 2I over 2. It's technically root z, not I, because you get it into a plus bi format, and then that's the square root. Yeah, okay, sure, yeah. Alternatively, you can treat it like Yeah, I know what you mean. So you treat this as z, and you find the square root of z. Which actually that wouldn't be that hard. I don't know why I'm saying that's that hard. Actually, I'm all of a sudden seeing how I could. So maybe we'll actually do it. But another way to do it is to say, what would that be? This would be root 2i root I. This thing could simplify to root 2i root I. And then you just need to know what root I is. But definitely not simpler. So why do that? Yeah, let's actually just find the roots. So now we're just going to treat this as we're looking for z squared if z equals 0 minus 2i. Oh, someone's going to say something? Maybe not? I guess not. So let's put this into polar form, right? So the r value is 2, right? So it's going to be z squared equals 2, 0 minus 1i. Okay, so cos theta equals 0. Sine theta equals -1. That sounds like, well, I shouldn't be so confident. I don't really know. Let's see. So this is sine inverse of -1 is negative pi over 2. Not what I mean. Because cos of negative pi over 2 is cos of negative pi, but we don't really want that. It is 0. Hold on. Where is sine theta equal to -1? Here at 3 pi over 4, right? Is cos of 3 pi over 4 0? No. What am I talking about? This goes like this. Wait. And then that here. Yeah, shouldn't that be 0? Shouldn't cos be 0 here? Unless I'm messing that up. 3 pi over 2. 3 pi over 2. Yes, 3 pi over 2. That's what I'm messing up. Okay, it's 3 pi over 2. And then sine of 3 pi over 2 should also be 3 pi over 2 should be -1. Okay, so our theta is... We could also have used negative pi over 2, but I don't think you're supposed to. Yeah, so that probably does work too. It's an angle. There's no reason it shouldn't, but I'm going to use 3 pi over 2 because it's between 0 and 2 pi. It's kind of more in our standard way of doing it. And it is also correct in both these statements. Cos of 3 pi over 2 is 0. Sine of 3 pi over 2 is -1. So there you go. So z squared equals 2. And I figured that out just by remembering the sine graph, right? Since we're looking for 0 and -1, I can pretty easily find where that is on the sine graph. Sine and cos graph. And yeah. So this is going to be cosine of 3 pi over 2 minus, plus, oh, too many s's on my sign, didn't I? Sine of 3 pi over 2 I. And so now I can write this as z squared equals 2e to the I 3 pi over 2. Okay, and now I will finally be able to take the square root of this. So the square root of this is going to be, plus 2 pi k, 2 pi. I always forget that until I'm about to do it. So z is equal to root 2 e to the I 3 pi over 4 plus pi k. Right? Okay, and so then there's two solutions. W naught, where k equals 0. So that's just going to be root 2 e to the I 3 pi over 4. And then I'm going to have to turn that into a standard form. And W1, where k equals 1. And that's equal, that's not a k, I don't know what I wrote there, but whatever. 2e to the I, and now this is going to be k is 1, so 4 pi over 4, so 7 pi over 4. And those are two solutions. Okay, and so now I'm going to turn this into standard form, so root 2 cos 3 pi over 4 plus sine 3 pi over 4i. So this is going to be cos, where's the fraction 3? Oops, 3 pi over 4 is, this is going to be root 2 times negative root 2 over 2 plus sine plus root 2 over 2i. And I can multiply this in. So this is going to be negative 1 plus I is our first solution. And since it's a square root, our second solution is just going to be 1 minus I. So that's W naught, and that's W1. Okay, so we can go back to here. And so our two solutions, x1 is going to be 3 minus 3i plus the first solution. So negative 1 plus I. So I don't even have to write this. So I'll write negative 1 plus I, still all over 2. So x1 is equal to 2 minus 2i over 2. So x1 is equal to 1 minus I. Great. And x2 is equal to 3 minus 3i plus the second solution, which is 1 minus I over 2. Right? So 4 minus 4i over 2, which is 2 minus 2i. And there's our two solutions for the quadratic. Those two. There we go. I thought I was going to get stuck with the root I thing. Yes, much easier. Just call it a z and then solve for the z and yada yada. Pretty good question. And I'll just quickly mention the linear. So the other question I was going to do was going to be, it gives you something like x. Ooh, not like that. X squared plus 16 equals 0. Obviously, you can solve this for the roots, but the question is asking, show this as a set. Oh, sorry. Show this as a set. Express this as a multiplying linear factors together, right? So maybe actually this is let's say it's power 4. So you would have 4 linear solutions. Those are your 4 solutions in standard form. You just multiply them together, and there's your solution. So that's how you write like you're factoring something, like putting something into factored form. But yeah. Okay, then that is chapter 6 done. Let's move on to chapter 1. Again, maybe I will actually put up a poll for if you want me to do maybe at the end I'll put up a poll for if you want me to do a session of just chapter 6 tomorrow. I will do it. Okay, so chapter 1. So I'll actually move this down to us down here. Come on. If there's a way to do this faster. Probably is. I can just copy and paste it, I guess. That would be a lot faster. But I'm almost there already, so I'll just have a sip of my tea in my math mug. Still very hot. Okay. So our next part is chapter 1. 1.2.12 is the first question. And here from Kuttler, so let's take a look at that. 1.2.12. I will be there in just 1 second. 1.2. I have to scroll a little bit. Give me just a second. There. So I thought these questions were kind of interesting. They're not super hard, but yeah, they're still good. So okay, so 1.2.12 is saying find H such that 2H 4 3 6 7, very small matrix, right, is an inconsistent system, which means it doesn't have a solution. I say that a little bit unconfidently. I forget what inconsistent means, but almost certainly means doesn't have a solution. Someone correct me. So so first let's try to put this into RREF or just REF, right? Do something with it. So I'll divide the first row by 2, right? So it's R1 times a half, right? So it's going to be 1 H over 2, 2, and then 3, 6, 7. Midterm 1 retake. Unless that person's not in the chat then. Oh no, they are in the chat, yes. Okay, and then now I'm going to do row 2 minus 3 times row 1. So 1 H over 2, 2, 0, 6 minus 3h over 2. 6 minus 3h over 2. And then it's going to be 7 minus 6 is 1. Okay, that took me 1 second. 1 second too long. Well, what we're really interested in is this down here, right? So if that equals 0, right? If that equals 0, then it's an inconsistent system because you have 0 times the first variable times plus 0 times the second variable. Well, that has to be equal to 0, but it's equal to 1. So the only time this is inconsistent is when this is equal to 0. Well, we can deal with this, right? So 3h over 2 equals 6. 3h equals 12. H equals 4. So when h equals 4, that's when the system is inconsistent. Yeah, makes sense. Okay, so then let's move on. So 1.2.13 is next. 1.2.13. Next couple questions are kind of similar, but definitely a good thing to practice. I think I just launched Skype. Yes, I did. You can see my... Okay, what's it not working? Okay, there we go. You can see my tutoring. So 2.2.13 is find h such that 1h3, 2, 4, 6 is inconsistent. So this one's actually simpler. So row 2 minus 2 row 1. So it's 1h3, 0. So that's going to be 4 minus 2h. And then it's going to be 6 minus 6 is 0. There is no h now for this to be an inconsistent system. So the only options are, is that true? Yeah. The only options are that either this term is 0 or it's not 0, or it's 1, right? So either 0 or not 0. So if it's 0, there's infinite solutions because you have a whole row of zeros. If it's any number except that, then there's one solution. So there is no h such that this has an infinite is an inconsistent. Oh, sorry. So the question is not inconsistent. The question is saying is the matrix of a consistent system, right? So any value of h. Never mind. I was gonna say even. So it's still any value of h will be right there. So 1.2.14. So similar. Maybe I'll skip the next one because we're kind of doing the same question over and over again here, but definitely a good thing to practice to know how to make it consistent and consistent. Okay, so this one's still going to be row 2 minus 3 row 1. So 1, 1, 4, 0, h minus 3, and then 12 minus 12 is 0. Once again, it's either infinite solutions or one solution. And those are the only two options. Yeah, those are the only two options. There you go. Same thing as last time. So 15. Maybe let's skip 15. Let's do 16. And you don't actually. System is consistent. 17 and 18 are not actually that good. We can scratch that off. I don't know why I went up to 18 here. So let's just do 16. And so 1.2.16. So 1.2.16 is saying choose h and k such that the augmented matrix shown has each of the following: one solution, no solution, infinitely many solutions. And the augmented matrix is 1, 2, 2, 2, hk. Right? Okay. I should open my Discord chat. Okay, no one said anything. Good. So that's h and that's k. Okay, so then I'm going to do row 2 minus 2 row 1. So it's going to be 1, 2, 2, 0, h minus 4. And then it's going to be k minus 4. Okay. So, what do we know, right? We're at this point now, so we have something on the last row here with the leading coefficient right next to the augmented thing. Well, if h minus 4 equals 0, let's do it part by part actually. So part A is one solution. Well, it'll have one solution if just so long as this does not equal 0. right? As long as that does not equal 0. So h does not equal 4. Then it'll have one solution if h is not 4. Because then this will be a number, and then it'll have one solution. Okay. B, no solution. Well, it'd have no solution if, if h is equal to 4, so this is a 0 here, and k is not equal to 4. So that means that it's a 0 and not a 0. So that means it's 0 times the first variable, 0 times the second variable equals something. Doesn't make sense, so that's no solution. Right? And C is infinitely many solutions. Well, that's if h equals 4 and k equals 4. Then it has infinitely many solutions because you have a row of zeros there on the bottom. Okay, good. So if at any point anyone has questions, just stop me. Let me know. Or just type in the chat or message me or anything. However you want to do it. Next, 1.2.9 in Nicholson. Okay. 1.2.9 in Nicholson.
Sorry, Adam, just a question.
Yeah, for
Were
sure.
the questions we did before, they were all from Kuttler, correct?
No, from the chapter 6?
From chapter 6 and chapter 1.
Yeah, they were kind of mixed. You can see on my list here which one, the ones with the N is the, if you want me to post this, I'll post this. I'll put it in the chat. These are the questions. And the ones with the N are from Kuttler, and the ones with the ones with the N are from Kuttler. Sometimes I don't know what I'm talking about. Yeah. The ones with the N are from Nicholson, the ones with the K are from Kuttler.
Alright, thank you, Adam.
No problem. No. Okay. Oops. So, although actually I should have removed, I should have actually edited this. Maybe I'll upload it again. That should be a 16. I don't want that. 17 and 18 are not that useful. I'll upload it again for people. Delete message. There you go. If you copy and paste something from OneNote, it pastes it to Discord as an image. Pretty useful. Kind of cool. Okay, 1.2.9 from Nicholson. 1.2.9. I gotta find it. 1.2.9. There we go. And did I say A or B? No, I guess I just didn't say A or B. Okay. But we'll do B, D. We'll do B and D in this case. Okay. So in each of the following, if possible, find A, B, and C such that the system has no solutions, one solution, infinitely many solutions. So 2x plus y minus z equals A. 2y plus 3z equals B. X minus z equals C. Okay. So we want, first of all, no solution. Okay, well, let's start with one solution. How do we know if it has one solution? Well, if A equals B equals C equals 0, then it's a homogeneous system, and then it has one solution. Okay, one solution's off the table. So no solution or infinitely many solutions. Well, now we're going to have to do some math. So 2, 1, minus 1, 0, 2, 3, 1, 0, minus 1, A, B, C, bars. And we're going to just do this a little, put this into RREF. So to do that, I will do row 1 minus 2, row 3. And I will do row 2, a half of row 2, which might be kind of stupid to do now, actually, but whatever. So that's 0. 1 minus 0 is 1. Negative 1 plus 2 is 1. A minus 2c is A minus 2c. This is going to be 0, 1, 3 halves B over 2, 1, 0, minus 1c. Okay, great. And so now, well, I'll just do, there's a couple ways I could do it, I guess, but I'm just going to do, it's not R, yeah, okay. I'll just do row 1 minus row 2. All right, so 0, 0, 1 minus 3 halves, so 2 halves minus 3 halves is negative a half. And then, well, this is just going to be A minus 2C minus A minus 2c minus B over 2, and everything else will be the same. 1, 0, 3 halves, B over 2, 1, 0, minus 1c. Good. Good. And then I'll just multiply row 1 by negative 2, and also move things around, so kind of doing a bunch in one go here, but here you go. C, 0, 1, 3/2, B over 2, 0, 0, 1. And then this will be negative 2a plus 4c plus b. Okay. Not done. Never mind. But actually, no. This we might be able to do it now. Actually, I probably could have done it from this step here. Anyways. Well, so I don't think it wants us to find every possible condition. Just find a set of conditions. In each of the following, find conditions on A, B, C. No, conditions. It wants every solution. Because I was thinking, well, I could pretty easily just do one example of a combination of A, B, C, but all A, B, C? So putting this into RREF wouldn't do anything. I don't think. No. Why would it do anything? Well, if I had a denominator, I could just say whatever's in the denominator. But I wouldn't be able to do infinite solutions. Is there a way to make it have infinite solutions? No, there's no way to make it have infinite solutions. Yeah, I think there's no way to make it have infinite solutions. Because we would need a whole row of zeros, and there's no A's on the left side. So there's no way we can make that a whole row of zeros. So there's no way to make... Definitely check this. Definitely check if I don't know if I'm right, but... So no way to make infinite solutions. One solution is A equals B equals C equals 0. And no solutions... Well, again, it looks like it has solution. It looks like it has, even here. How can this not have a solution? It has a leading coefficient in every leading. I always say the wrong word. Leading entry in every column. So it looks like it has to have a solution. Does anybody have any input that they're thinking about this? I'm gonna check the answer. What was it? 1.2.9. B, unique solution, x equals. Did I read the question wrong? No. Did I read the question wrong? Yeah, so it looks like... What's going on? What? Did I do something wrong? Z equals... Oh yeah, something I did a little wrong here. I made some mistake in the math. This should be a coefficient of 1 on that. I don't know how. But yeah, the solution says the solution. It doesn't say there's no way to make it infinite solutions or no solutions. But the answer it says unique solution, x equals this, y equals this, z equals this for any ABC. So that's the answer. You can't make it have no solutions. You can't make it have infinite solutions. It will always only have one solution at x equals whatever it says on the screen. Here, actually, I'll just show you. I don't know why I was explaining it. Right here. There you go. So that's the answer. So I was right. Just didn't. I made some mistake in my reducing here, my elimination. So let me. What's my next question? 1.3.5. Oh, actually no. Let's do another one of these. Let's do another one of these, but part D. Oh, someone's saying something? Oh, no. It might just be background noise. So this was, I forgot where I was already. 1.3.5 from applications. 1.3.5. No, I'm reading the wrong thing. Sorry. It's already, I don't know. I don't even know what I'm saying. 1.2. Okay. So now this one. Actually, let's just do F because F will be the harder one. So it says x plus ay minus z equals 1. Negative x plus a minus 2y plus z equals negative 1. 2x plus 2y plus a minus 2z equals 1. So find just a. Yeah, there's no b. Okay, well, so already a simpler question, but find a such that this has one solution, no solution, infinitely many solutions. Okay, so I'll first make a matrix. 1a minus 1, 1, negative 1, a minus 2, 1, minus 1, 2, 2, a minus 2, 1. Good. Then I'll get going. So row 2 plus row 1, row 3 minus 2, row 1. So 1a minus 1, 1, 0, 2a minus 2, 0, 0. Well, we already kind of have our thing for the answer, so we don't even have to do this. But anyway, so row, so that's 0. 2 minus 2a, 2 minus 2a. A minus 2 plus 2 is a. And 1 minus 2 is a minus 1. Okay, well, we actually already have all we need to know. So this column right there. So if this has, actually, maybe we could do a little bit more. Oh, no, actually, yeah. No, we don't actually. We probably could find some information there, but not everything. So let me just go all the way to the end, and then we'll do it. So I will do row 3 minus row 2. Oh, no, never mind. That's... Okay. First, I'll multiply this by negative 1. So I'll just do that here. So that's 2 minus 2a. And now, row 3 minus row 2. So that'll be... Yeah. 1a minus 1, 1, 0, 2 minus 2a, 0, 0, 0, 0. Oh, I could have just added before, and that would have done the same thing. Okay, great. Minus 1. Okay, now we have all we need to know. So first of all, one solution. No, okay, first of all, no solutions if a equals 0. If a equals 0, that means no solutions. Okay. Infinite solutions are if, so a can't be 0, right? But let's look at this row. Infinite solutions are on a row of all 0. So how does this equal 0? 2 minus 2a equals 0, right? So 2a equals 2, a equals 1, right? So if a equals 1, infinite solutions. Okay, and if we want just one solution, then anything else, I think. Yeah, then it can just be any other number. Yeah. A does not equal 0 or 1. No, one solution. Right? Because if you just try any other number and then it'll work. I think. Yeah, exactly. Okay, there's that question. Any questions about this? I should have some sort of chat thing on top, so I don't have to click into Discord all the time, but that'd be too streamer. So, yeah, I'll move on. 1.3.5. 1.3.5. Again, I should just bring this down. I don't know why I don't. From Nicholson, of course. 3.5. So this is here for each. Oh yeah, this is a weird question. Honestly, I don't even know if I looked at this question. I was like, I don't know how to answer it. So that's why I put it here. So maybe we can figure it out together. So for each of the following homogeneous systems, find a set of basic solutions and express the general solution as a linear combination of these basic solutions. Maybe I understand? Okay. I just feel like I don't understand the word. So b is x1 plus 2x2 minus x3 plus x4 plus x5 equals 0. Yeah. Minus x1 minus 2x2 plus 2x3 plus x5 equals 0. and minus x1 minus 2x2 plus 3x3 plus x4 plus 3x5 equals 0. So our matrix is 1, 2, minus 1, 1, 1, 0, minus 1, minus 2, 2, 0, 1, 0, minus 1, minus 2, 3, 1, 3, 0. Okay. I'm trying to think. How would it, yeah. Well, I can solve this. I mean, we can solve. I mean, we'll see it's okay. Well, right off the bat, I know I'm going to have infinite solutions. How do I know this? Oh, this should be a thing here. Well, because look at how many leading I say the wrong word always. Leading entries can I have? Well, I can have maximum of 3, right? That would be the maximum. And then I'd have 2 parameters. Assuming everything goes well. Assuming it's not infinite solutions. Oh, sorry. Then it already is infinite solutions. Never mind. Yeah, so then I'm saying what I just said was assuming it's not infinite solutions, it's infinite solutions. Anyways, so I'll just do the row reduction. So row 2 plus row 1, row 3 plus row 1. So 1, 2, minus 1, 1, 1, 0, 0, 0, 1, 1, 2, 0, 0, 0, 2, 2, 4, 0. Okay, well, we can already see we have a parameter, right? And then I'll do row 3 minus 2, row 2. So 1, 2, minus 1, 1, 1, 0, 0, 0, 1, 1, 2, 0, and then 0, 0, 0, 0, 0, 0. Okay. So we have infinite solutions, right? We can tell already. And I guess I'll just do one more step. So I'll do row 1 plus row 2, 1, 2, 0, 2, 3, 0, 0, 0, 1, 1, 2, 0, 0, 0, 0, 0, 0, 0. Okay. So what this tells us is that we have x1. Okay, so x1, x2 equals t, x3, x4 equals s, x5 equals p, right? So x1 equals minus 2t minus 2s. I shouldn't use s. My s's look bad. I'll just use q. My s's look like 5s, so it's going to be confusing. Minus 3p. x2 equals, oh, I guess find a set of basic solutions expressed linear combination. Oh, okay, never mind, I understand. Okay, so x2 equals t, x3 equals minus q minus 2p, and then x4 equals q, x5 equals p. Okay, so there's our solutions, right? So t, p, and q are all they're all parameters, and so I can express this as a linear combination because we can just put all our variables to the side. I mean, they already are on the side, but just in a vector, and that can be equal to, well, each parameter one at a time. So there's no number, right? There's no values here, right? So we can just say this is equal to, well, let's start with the t's. So the first one has minus 2, minus 2, 1, 0, 0, 0. And so it can be written as t times that plus, next let's do q. So q times, well, negative 2, 0, negative 1, 1, 0. Plus p, and then p is the last one. So negative 3, 0, negative 2, 0, 1. And there you go. So that's the general solution written as a linear combination of the parameters. I just didn't understand the wording when I heard it, but yeah. Find a set of basic solutions and express the general solution as a linear combination of these basic solutions. There we go. Beautiful. Okay, and I think that's the end of chapter 1. yeah, that's the end of chapter 1, and it's 9 o'clock. So I think that's perfect timing. That'll be it for the session today. Okay, guys. Here, I'll switch my thing back here. Okay. Hello. So I hope that was useful to everybody. I hope everybody had a nice time doing some math with me. We will have another session on Thursday at 6:15. That'll be right after my linear algebra lecture. And then next week, for sure, we're going to have a lot of stuff to do for the test, because for the test number 2, because there's a lot to unpack there. I mean, the first half of chapter 4 is okay. And then I feel like 4.10 is very strange, but I've been watching some videos and I think I understand. So hopefully we can spend some time doing some work like that. I hope you guys like the stream layout and everything. I guess
we love it.
Yeah, thanks. I'm happy with it. And maybe I even have, I didn't show it because I didn't need to use it, but I even have AFK back and I put a time in there. That's my. Anyways, I set up any other suggestions you have. Maybe I'll try to get music working. I don't know. I haven't gotten music working. I'll stop the recording. I could stream on Twitch. I have looked up math